evaluating the integral that goes from 0 to 1 of 1 over x minus 1, and dx is what we call the differential element. Alright, this is a bit of a struggling student's guide. So first, look at this information. There's a 1 here and there's a 1 here. That's important to understand. Let's make a picture of what's going on with this. Okay, relate the integral to a picture. So I'm going to do this here. Make this the x-axis here. And then this will be our y-axis here. Now, look at our integral. It says the integral from 0 to 1 of 1 over x minus 1 and then dx. This 0 means x is 0 right here. This is x equals 0. The 1 here means, more or less, let's say this is 1 right here. Okay, this is x equals 1 right here. But the 1 has a very specific impact. So look at it. We have 1 over x minus 1. So like x minus 1 cannot be equal to 0. So to avoid division by 0 here. So x cannot be equal to positive 1. That means you got to draw an asymptote where x equals positive 1. Okay, so that means something like this pretty much. You indicate it with a dashed line that looks like this. Now, at x equals 0 over here on the left side, we have 1 over 0 minus 1. So that's 1 over negative 1, which is negative 1, and that's our y. So when x is 0, y equals negative 1 is what comes out. Let's say that this is right here, okay? This is y equals negative 1. Negative 1. So we're going to try to find this area. Now this part is easy, no problem, but look what happens when you start getting closer to 1. Here, the graph starts going towards negative infinity, and you have here a gap. This gap never goes away, and like specifically here, you start accumulating a lot of area here, right? In this very thin strip. But what happens is the graph goes towards negative infinity. So there's always a gap here. It never goes away. That means you're always accumulating a bit more, a bit more, a bit more. Okay. Now remember, here when you're integrating from 0 to 1, that's like this here. This interval. The 1 is excluded, but the 0 itself is included. So now for that reason, look what happens. Especially over here, you got to imagine you're approaching 1 from the left side. You're approaching 1 from the left. So you will say x is approaching 1 from the left side with the negative. Got it? So this thing has to be incorporated somehow in one form or another. The evaluation of the integral. The fact that x equals 1 is the vertical asymptote. That means you can approach x equals 1 but never reach it. Okay. Approaching is not reaching, correct? You can approach something forever without ever reaching it. Okay. So we're going to do the following now. The limit as t, not x, goes to 1 from the left side of this integral. So the 0 is not a problem, but because 1 is a problem, this t goes up here, right? So like t here now and t up there, got it? And then it's going to be 1 over x minus 1 dx. So why t suddenly when everything that we have seen here so far has been in terms of x alone? Okay, so the reason is something like this pretty much. People try to write it as the limit as x approaches 1 from the left of the integral from 0 to x now. They put x here and here, and then you have 1 over x minus 1. So you have x here and then dx. So you end up with like an x here, and x here. It gets confusing with all the x's floating around. So you can just use t for that reason. Anyway, let's evaluate. Now this expression here, so hopefully you know that's just ln of the absolute value of x minus 1. So you got to know that from a lower level calculus class. Alright, here it's just using these facts with improper integrals. So I will have the limit as t approaches 1 from the left of ln of the absolute value of x minus 1 evaluated between t and 0. This is what's left from our integral here. Hold on, this writing. You know, these apps still leave a lot to be desired. Okay. Alright, so we're going to do the limit as t approaches 1 from the left side of ln of t minus 1. Okay, so be careful here. You're putting in here, right, for x. You're replacing x with t now. And then minus the limit as t approaches 1 from the left side of ln of the absolute value of 0 minus 1. So again, you're putting in 0 for x in that position. We have two limits to be found. The one on the right is the easier thing to do here. Okay, let's work on that then. This one here, I'll do this one separately, okay? So you have the following. Negative limit as t approaches 1 from the left side of ln of just negative 1. Yeah, so this expression is coming down as negative 1. So minus the limit as t approaches 1 from the left side of ln of positive 1. So now this is coming down to just positive 1. For this last part, it helps if you know the basic ln function looks like this. Now because t is our variable, you can call this the t-axis. This is t equals like 1, so you have ln of 1, which is 0. So you end up with negative limit as t approaches 1 from the left side of just 0 from here. Okay, so this is 0, this is 0. And of course, the limit of a constant is the constant. So this is just ends up being 0. The limit, negative, of t approaching 1 from the left of 0 is just the 0 itself, right? This is what comes down, the constant. So all these basic rules from Calculus 1 always apply. Pre-calculus applies. Everything always applies in math, right? This is like the ultimate form of a cumulative subject. Okay, brick by brick. Okay, so limit as t approaches 1 from the left of ln of the absolute value of t minus 1. This thing perhaps requires a bit more consideration. Let's do it with a graph so it's visual. Alright, so I know this ln of the absolute value of t minus 1. I'm doing it with a graph because you can put it into your calculator and graph it yourself and see you should get something similar, okay? So first of all, this is going to be an asymptote here. Why? Because we have ln of the absolute value of t minus 1. So if you do ln of 1 minus 1, so I'm putting in t equals 1 here, you can have ln of 0, which is what? D and E. This does not exist. Okay, so this is... And then the rest of the graph looks like this. Right, so this is saying, again, when we approach t equals 1, so t is approaching 1 from the left side, ln of the absolute value of t minus 1, so that's this curve here, ln of the absolute value of t minus 1, this is approaching negative what? Infinity, right? Negative infinity down here, correct? Negative infinity. Again, there's a gap. So that means the following, the limit as t approaches 1 negative, I'm sorry, I keep saying that, 1 from the left side of ln of the absolute value of t minus 1, this is negative infinity. So now we have this case of negative infinity and 0. This is the one that, let's say, wins, and this one loses. So that means the following overall is what holds. This integral from 0 to 1 of 1 over x minus 1 with dx, this whole thing, basically we say that it does what? It diverges. Okay? But the reason I've explained specifically like this part. Okay, anyway, if you like these types of videos, please be sure to subscribe and like and share. Thank you so much for watching. Have an amazing day. If math seems difficult, what you can do to overcome any difficulty is just embrace the art of being very persistent and never ever giving up.